Hello everyone, I'm Bingja. Welcome back to another video. And in today's video, it's gonna be relatively short, I guess. I'm just gonna cover a few topics: is indices, decimal points, significant points, and standard form. So without further ado, let's go. So the first thing we're gonna talk about here is about indices. So indices is like the powers of integers. So for example, a to the power of 2, a to the power 3, as stated from the last video. So there are a few rules of indices that I'm going to introduce to all of you. So the first thing is when a to the power of m multiplied with the a to the power of n, we can simplify it as a to the power of n plus n. So no proof required. This is like the rules of indices. All right. So okay, I'm just gonna write here the rules of indices. All right. So the second one is when a to the power of m divided by a to the power of n, it's equivalent to a to the power of m minus n. So these are the normal and simple ones that you will need to know. All right. So the next one is a to the power of negative m is equivalent to 1 over a to the power of m. Right. So when you have a reciprocal, then it's to the power of negative, as stated from the first video. So next we're gonna look at the when fractions. So a over b to the power of m is equivalent to a to the power of m divided by b to the power of m. Okay, so these are just stuff that you need to remember because the rules are as so. So when we talk about a over b to the power of negative m, all right. So this is a little bit interesting because we can first flip both of them. All right, is equivalent to b over a to the power of m. All right, there's a little proof here. If you want to ask why can we just flip like that, so I'm gonna do a little bit of proof here. So a over b to the power of negative m. If we according to rule number 4, we can just bring in the power. So it's a to the power of negative m divided by b to the power of negative m. So if we further continue, it's equals to 1 over. Right. So it's equivalent to 1 divided by a to the power of m divided by 1 over b to the power of m. So by simple math, you can actually see that this is equivalent to this, and therefore equals to b over a to the power of m as shown. All right. So this is a little bit of proof that why we can just flip the the fraction if we get a power of negative. Okay, so after all these, we will look at some simple. We will look at some simple calculations of uh by using the laws, the rules of indices. Okay, so let's see. How many spaces do we have? Okay, a lot more. So, oh no, 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 oh no. Why is it like that? All right. So first, we're gonna go to examples. All right. So the first example here we have let's say 2 to the power of negative 3 times 2 to the power of 4. If you are to expand everything, only you calculate, it will be very slow because it gonna takes you like 1 over 8 times uh 16, then only you will get it's 2. It's a little bit slow. So instead, we are going to use the rules of indices when a to the power of m multiply a to the power of n, we gives a to the power of n plus n. So 2 to the power of negative 3 times 2 to the power of 4 is equivalent to 2 to the power of negative 3 plus 4. All right, so this will give you 2 to the power of 1, which gives you 2. All right, so let's see the second example here. It's actually it's not an example. This is just something that you need to know. All right, I'll show you in the next canvas. All right, I'm back. All right, so next one, I'm gonna tell you guys something about a to the power of zero. All right, so this is a very special case. A to the power of zero is equals to one, and where a is any integer. All right, a is an element of integer. All right, so anything power to zero is equals to one. So I won't do a lot of proving in this video. You can go watch other famous mathematics YouTube channel like Mr. Eddie Wu and stuff. I will put the link somewhere here. It's basically something like a sequence. So let's say 2. All right, if a is equals to 2, all right, we're gonna compare 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. And we all know that this is actually equals to 2. All right, this is equals to 2, this is 4, and this is 8. So if we are going to look at the sequence, 8 is all right, 8 divided by 2. All right, 8 divided by 2, you will get 4. And if you divide by 2 and it goes to 2, so if you are going to go back one more time, divide by 2, you will get 1. So uh, yeah, and if it's -1, then it's 1 over 2 because it's divided by 2. So this is why anything power to the 0 is equals to 1. All right, but there's one thing to know here. For a is not equals to 0, because if it's because there's another theory behind here. All right, so this is number one, and number two is 0 to the power of anything. All right, for a is a real number. All right, for a is a real number is equals to 0. All right, for example, 0 to the power 1, 0 power 2, 0 power 1000, everything is equals to 0. All right, so why is there a not equals to 0 right here? Is because if you notice, it is kind of contradicting. All right, if we are talking about one thing to know is, how about what is 0 to the power 0? All right, because if we say anything to the power of 0 is equals to 1, but 0 to the power of anything is equals to 0, so what is this? Right, so if you want to watch stuff like this in this video, if you want to watch like why what is 0 to the power of 0 and how do you explain that, you can go to Mr. Eddie Wu's YouTube channel. That's where I watch all those about 0 to the power of 0 stuff. So I will put the little card up here so you can go and visit that YouTube channel if you don't already know him, I guess, because he's so famous, right? So okay, before I go to the next part, I'm gonna give you one last example. One last example on indices. All right. So this is a little bit example on indices by using the rules of indices to solve this. All right. There are two methods to do this. One is with using your calculator, but usually in exams, they will ask you to evaluate. All right, if it's evaluate, you cannot use your calculator. All right, cannot use your calculator because they expect you to show steps on how you get the answers. Okay, so from here, if we are gonna write like this, 3 divided by 3 to the power of 8. All right, so according to the rules of indices, we can get that. I'm sorry, this OBS Studio is a little bit laggy. So 3 to the power of 4 plus 7 minus 8. All right, from these two rules, a to the power of n times a to the power of n is equals to a to the power of n plus n, and a to the power of n divided by a to the power of n is equals to a to the this one. So at here, a is equals to 3. Okay, a is equals to 3, and you will get all these. You will get 3 to the power of 3, which gives you the final answer to be 3 to the power of 327. All right, so this is a little bit of example on how to use the rules of indices to solve questions like this. All right, of course, in exam, it will be a little bit more complicated. We will show this in the future past year exam papers. I'm going to do it out. All right. So, all right. So we're going to go to the next part, which I'm going to talk about decimal places and significant figures. Just let me clear this canvas real quick and I'll be back. All right. So in this part of the video, I'm going to be talking about DP and SF. Alright, so this is a very important part because it plays a very major role in both maths and sciences like physics or biology or chemistry when the question asks for a precise DP or SF. So what is DP and SF? So DP is mean as decimal places or decimal points or a lot more. SF means significant figures. All right, so let's talk about what is the difference between DP and SF. Okay, so we're gonna be having a little bit example here. Okay, I will write a big EG here. Let's say 3 38 point 38.00870500. All right, so we're gonna take this number to give an example for both DP and SF. So, okay, here we're gonna define how many DP. All right, so for DP decimal places is the number, is the amount of numbers, amount of digits behind the decimal point. All right, behind the decimal point. All right, so in this example here, we have 00870800. So we have an amount of 8. All right, so this is 8 DP. Okay, you can just calculate by seeing how many DPs is behind here. Okay, so this is about the DP for this. And the next is big one. All right, so the second one is how many significant figures. All right, significant figures is the amount of digits of the whole thing without, all right, without what? With, all right, uh, without leading zeros and edging, not edging, sorry, trailing and trailing zeros. All right, what is the example here? Is we can see from the one above, there are no leading zeros, so we're going to calculate from here onwards. All right, 1, 2. All right, trailing zeros are the zeros at the back, so we calculate the zeros in the middle: 3, 4, 5, 6, 7, and 8. So this number contains of a total of 8 significant figures. These are trailing zeros. All right, these are trailing zeros. So this is the difference between decimal points and significant figures. So for decimal points, you need to include everything behind the decimal point. Okay, so for significant figures, you ignore the leading zeros and the trailing zeros, and you include everything in between. All right, even the zeros in between the numbers. Okay, so this is about decimal points and significant figures, and I'm gonna be talking a little bit about the decimal places. Okay, so from here we have let's say 0.000001. Okay, so there are numbers here. I believe that you know all the names for this. So this is ones, this is 10, this is hundreds, and this is thousands, and so on. All right. So you have been learning this since young. So I believe you already know all these. This is just a little bit of recap here. This is tens. This is hundreds. And this is thousands with all the th behind. Okay. With all the th behind and so on. All right. So if you are to, if the question gives you, for example, 38.5691. All right. They ask you to correct, they ask you to correct this to 2 decimal points. All right. So from here, we will write like 38.5691 is almost equal to 38.57 because they want 2 decimal points, which gives you two numbers behind this decimal point. All right. And why is it 7? Why is it 7? It's because 9 is larger than 5. So we will add 1 into this second one. I believe you already know all these. All right. So in this part, what if the question asks us to correct to 3 significant figures? All right. So 3 significant figures is which means we need only 3 numbers up here. So we need 1, 2, and 3. All right. Of course, we need to take the one in front. So it's 38.6. Why is it 0.6? Because if we look at the one after the requirement, 6 is larger than 5, larger or equals to 5. 6 is larger or equals to 5. This also. So we need to plus 1 to the 5 here. So it's 38.6. Okay, so it's equals to, or what if the question asks us to correct to 10 tenth. All right, so if we are to see what is correct to tens, 38.5691, this is the 10th. And if we are to refer to this, then we will know that it's the same thing as 38.6. So this is the accuracy part. So you need to correct all these. And yeah, this is all about the accuracy. And we're gonna proceed to the last part of this video where I'm gonna be sharing about standard forms. All right, so I will clear the canvas and be right back. So in this last part of the video, I'm gonna be sharing with you something called as standard form. All right. So this standard form is a little bit important too because maybe some of the sciences you will need to learn about that, and of course in this maths. So standard form, we will say is something a times 10 to the power of n, where a is in between, is larger than 0 and lesser than 10. All right. Or we can, yeah, it's basically like that. Wait, cannot be cannot be larger than 0. We will say it's larger or equals, oh no, where a is larger or equals to 1. All right, so a needs not to be an integer, but n must be an integer, and n is an integer. All right, I believe so. So what is the meaning of standard form? All right, so what if you have a very large number, for e.g., oh no, okay, for e.g., we have a very large number like 1000. All right, convert 1000 to standard form. I'm just, oh no, I can't do that. All right, convert 1000 to standard form. So we know that standard form is in the form of a times 10 to the power of n. So how do we do that? So we know that a is lesser or is more or equals to 1. So if we are following this, it will be 1 times 10 to the power of 3, right? because the decimal point is here. If we are moving backwards, 1, 2, 3, until we get the number that satisfy the characteristics of a, right, which is 1. So times 10 to the power of 3, and we get this is equals to 1000. So this is one of the easiest example here. I'm gonna bring it a little bit harder ones. For example, e.g. number 2, convert 39563000 to standard form. All right, how do you do that? So the same thing is we're gonna push our decimal point backwards until we get to satisfy a. All right, so from here we're gonna move all the way backwards here. So we will get 3.9563000 times the amount of power of tens until you get back to this. So from here we go 1, 2, 3, 4, 5, 6, 7. So it's times 10 to the power of 7. Only you will get equals to the number here. But however, we can ignore all this zero at the back, so we will write as 3.9563 times 10 to the power of 7. Alright, so this is the answer for converting this big number here to standard form. What if the question wants to convert this into standard form but in 2 decimal places? Alright, then from here, 3.9563 times 10 to the power of 7. If we need 2 decimal places only, then we will refer to the third one, which is larger equals to 5. Therefore, this needs to be plus 1. So it will be equals to, or we will write this wavy form here, 3.96 times 10 to the power of 7. Or it will go the same to 3 significant figures. Alright, so this is all about standard form, and of course, it's all about this video. So if you have any questions, please do go to Instagram and you can direct message me, or so that I'll try my best to help all of you. So I hope you guys will understand this one, and I'll see you guys in the next video. Thank you for watching.